Hello everyone. We'll move on to the next topic under module 3 of computer communication network. So this particular topic deals with network layer. So today we'll learn about different addressing mechanism used in network layer. As we already studied in the earlier classes, network layer lies between the data link layer as well as transport layer. So the network layer in TCP/IP protocol is responsible for host to host delivery of datagram. It also provides service to the transport layer and receives the services from data link layer. The address mechanism used in network layer we call it as IP address. So what is this IP address? It is defined as an identifier used in IP layer to identify the connection of each devices to internet is called internet address or IP address. There are two version of IP addresses, or there are two types of IP addresses. So one we call it as IPv4 addresses, second one is IPv6 addresses. IPv4 was the earlier version, and the later, based on the requirement, the new version which is called as IPv6 has been identified, or we are using it now. When it comes to IPv4 addressing, it is 32-bit long. So the size is 32-bit long in case of IPv4, and it is unique and it is universal. So each devices will have this unique IP address. So since it is 32-bit long, so we can address up to 2 to the power of 32 devices, that is more than 4 billion systems we can address using this IPv4 addressing scheme. Now let us see how this addresses can be denoted. Okay, so we'll see the notation of this IPv4 addressing. So in case of IPv4, basically we use three different types of notation. So first one is binary notation, second one is decimal dotted notation, and the third one is hexadecimal notation. So as you can see in the slide, so the first one whichever is mentioned using the data 1000000 space 00001011 space 00000011 space 00011111. So whatever we can see the address in a form of binary numbers, we call this as binary notation of a IPv4 address. Okay, so each space consists of 8 bits separated by a space. The same thing we can represent using decimal dotted notation. So each part, as I said, 8 bits, the equivalent of that in decimal will be written, and each decimal number is separated by a dot. So that's why we call it as dotted decimal notation. For example, if you take the binary number, the first one 10000000, which is nothing but the equivalent in decimal, it is 128. Similarly, the second one 00001011, which is nothing but 11 in case of decimal. Similarly, the binary number 00000011 is nothing but 3. And similarly, the last one 0001111, which is nothing but 31, the equivalent of that in decimal. So this is how we represent in decimal dotted notation. Similarly, we can represent using decimal notation the same way whatever the decimal number we have, we'll write its equivalent in hexadecimal. So equivalent of 128 in hexadecimal it is 80, and equivalent of 11 it is B, equivalent of 3 it is 03, and equivalent of 31 is 1F. So any one of the notation we can use to represent the IP address. It may be binary, it may be dotted decimal, or it might be hexadecimal number system. So before going in depth of this IPv4, let us just take one small example wherein we'll see what is the mistake or the error in the given IPv4 addresses. So as you can see in the example, the first one A, it is 111.56.045.78. So this is the address which is given. So this is the IP address wherein it is represented in decimal dotted or dotted decimal notation. So the error in this particular case is when we take the third digit, that is 045. So in case of any IPv4 addresses, the decimal should not begin with 0. So that is a one mistake. So instead, if it is 111.56.45.78 is a correct answer. When we take the second case, it is 221.34.7.8.20. In this case, there are total 5 digits. As I said in an earlier case, so it should have only 4 digit numbers. Okay, so here we have 221, that is 1, 34 2, 7 3, 8 is 4, 20 is 5. So there are 5 digits, so it should have only 4 digits. Okay, so that is the error in the second case. Third one, it is 75.45.301.14. See, in this case, the third digit 301. Okay, so if we take any number in case of a binary, it is represented by 8 bits. So when I take all the bits is equal to 1, that is 1111, 1111, that is all the 8 bits is equal to 1, then the number in decimal, it is 255. Okay, but here the number is given as 301, so it exceeds 255. So that is the error. So whatever the number we give, it should be from 0 to 255. It should not cross that 255. And the last case, it is 111.00010.23.14.67. So in this case, it is a mixture of binary number as well as decimal number. So either the address should be represented in binary notation or in dotted decimal notation, and we can't use the mixture of both. So that is the error in case of the fourth one. Now let us move on to the further classification in IPv4 addressing. Basically, the IPv4 addressing is further divided into two types. One is called as classful addressing and second one is classless addressing. So one as I said, one is classful addressing and one more is classless addressing. So before getting into classful and classless addressing, so first we'll define why this is called as classful addressing and one more is classless addressing. As in case of telephone network or in postal network, even in case of IPv4 has hierarchy in addressing. So whatever I said, there is a 32-bit, so it is divided into two parts. So first one we can call it as prefix, second one we call it as suffix. You can see in the diagram there are two parts, one is prefix, one is suffix. So the n bit, the first n bit will be represented as prefix or we call it as prefix, and the next remaining, that is 32 minus n bits, we call it as suffix. The first part, whatever we call it as prefix, can be of fixed length or of variable length. If prefix is of fixed length, then we refer it as or we call it as classful addressing, whereas the prefix with variable length we call it as classless addressing. I repeat, a prefix with fixed length we call it as classful addressing. A prefix with variable length we call it as classless addressing. So first we'll go with classful addressing. As I said, here the prefix length is fixed. So when internet was started, so IPv4 address had fixed length prefix, and this length was designed to have either 8-bit, 16-bit or 24-bit, and entire address space was divided into 5 classes. So this method or this scheme we call it as classful addressing. As you can see in the diagram, in case of class A addressing, network length is of 8-bit and the first bit is 0. That is, in the class A addressing, in classful addressing, there are 5 different types based on the size of the prefix. So first one we call it as class A, second one as class B, third one as class C, fourth one as class D, and the last one as class E. So depending upon the length of the prefix as well as the first bit or few bits will decide which class of addressing under classful addressing. So in the first case, you can see in case of class A, the length of prefix is 8-bit and the address will start with 0. So this type of classful addressing scheme we call it as class A addressing. So since it has got 8-bit prefix and first bit is 0, so we have only 7 bits to represent the network identifier. So total will have 2 to the power of 7, that is total 128 network we can have in case of class A address, or we will have only 128 addresses under class A. In case of class B, as you can see, the network length or the prefix length is of 16-bit. You can see 2 8-bit and 8-bit, so total 16-bit, and the first 2 bits has to be 10. So if any address whose address starts with 10, then we call that as class B addressing. So all the addresses will start with 10. Similarly, if the first 3 bits are 110 and the prefix length is of 24 bits, then we call that kind of addressing as class C addressing. So first 3 bits has to be 110 and the prefix length or the network length has to be 24-bit. Similarly, we have something called class D addressing. So it does not have any suffix or prefix. However, this is used for multicast addressing. Okay, so we'll be used for multicast addressing, and the address always starts with 1110. So any address which begins with 1110 followed by the rest, we call those kind of addresses as multicast address. And the last one we call it as class E addressing, wherein first 4 digit will be 1111 or the first 4 bits will be 1111, and this is kept for future use. So the class E addressing presently we are not using, that is kept for future use. And the same concept has been explained in this particular flow diagram. So start, check for the first bit. If the first bit is 0, then directly it is nothing but class A. If first bit is 1, then we'll check for the second bit. We'll check whether it is 1 or 0. If the second bit is 0, that is first bit is 1, second bit is 0, then it is nothing but class B. Even the second bit is 1, then we'll check for the third bit. First bit is 1, second bit is 1, so it will come to the third bit. So here we'll check for the third bit. If third bit is 0, that is class C, and if it is 1, then we'll go on check for the fourth bit. So if fourth bit is 0, then we call it as class D address. And even in this case, if it is 1, that is all the 4 bits 1 1 1 1, that is first bit is 1, second bit is 1, third bit is 1, fourth bit is 1, then we call it as class E. So we'll take one example here. So we have got 4 numbers or 4 addresses. So let us see whether they belong to class A, class B, class C, class D or class E addressing. The first case it is 0 0 0 0 0 0 0 1 0 0 0 0 1 0 1 1 0 0 0 0 1 0 1 1 and 1 1 1 0 1 1 1 1. So we need to check only the first bit. So first we'll check the first bit. When we check the first bit, it is 0. Since the first bit is 0, directly you can say it is class A addressing. Similarly, we'll check the second address. Second address is 1100 0001 1000 0011 0001 1011 1111 1111. So in this case, the first two bits are 1 1 and the third bit is 0. So we know if first two bits are 1 followed by third bit is 0, then it belongs to class C addressing. The third one, it is 14.23.120.8. So since it is given in decimal dotted notation, first we'll check whether it is comes under class A, class B or class C or D or E based on the first two digit. We have 14, so 1 represented as 0001. So since the first bit is 0, we can directly say it is class A addressing. In the last case, it is 252.5.15.111. So 252, that is all the bits are equal to 1111. So obviously it comes under class E addressing. So class E addressing. The next topic is address depletion. So the problem associated with classful addressing is the address depletion. That is, addresses were not distributed properly. Let us consider class A addressing, in which only 128 organization can be assigned because the first bit is 0, remaining is for prefix, so remaining 7 bits, so it is 2 to the power of 7, which is equal to 128. So we can use only up to 128 organizations to use class A addressing. But if the organization require very large number of addresses, then we can't go with that. So most of the addresses in this case, so as I said, we can name up to, or we can consider only up to 128 organization. But when we see the suffix, we can address up to 1 crore devices in that one particular network. So in one particular company or in one particular organization, having more than 1 crore devices is just imagination. So we most of the companies will not have that devices more than 1 crore. So the lot of addresses will be wasted when we consider class A addressing and class B addressing. But when we take class C addressing, here problem with this is, so only few addresses will be available under class C addressing. So there will be shortage of addresses in case of class C. So in first two cases, that is class A and class B, the number of organization we can assign is less, but for that particular organization we can assign more than 1 crore addresses, or we can use more than 1 crore devices in that organization. But companies will not have those many terminals or computers, so most of the addresses will be wasted. Whereas when it comes to class C, the number of organization we can address is more, but the device addresses will be less. So this is the problem associated with class full addressing. So to overcome this problem, there are two solutions. One is called subnetting, second one is called supernetting. So these two strategies can be used in order to overcome the problem of classful addressing. In case of subnetting, class A and class B block is divided into several subnets. So we can divide, using this address we can divide the group into block into several subnet. So in this case, each subnet will have large prefix length than the original network. So we can have a variable length, that is of larger prefix compared to the original one. Similarly, the second one we call it as supernetting, wherein we can combine the so many class C blocks into a large block. So subnetting, where we increase the prefix length and will distribute to the devices in the network, whereas in case of supernetting, we combine several class C blocks and we make it as a large block so that the organization will get multiple or more addresses.